Hello everyone, you are welcome to my channel. This is 2023 NECO Physics Past Question Solution Series. Here we are in question 16. If you have been following us, we've treated question 1 to 15. Today we start from question 16. And question 16 says, the temperature of land rises faster than that of sea when heated by sun because land has larger surface area than the sea. B, has lower specific capacity than the sea. C, it is a poorer absorber of heat. D, is denser than the sea. E, receives higher quantity of heat energy than the sea. The correct option here is option B. Land has lower specific capacity than the sea. What is specific capacity? It is the quantity of heat required to raise the temperature of unit mass of substance through 1 Kelvin of temperature. So this implies that land has lower specific capacity. It shows that it takes little amount of heat to raise the temperature of land compared to that of sea. That is why it is the temperature of land rises faster than that of sea. That is option B. So question 17 says, which of the following factors will affect both specific capacity, both boiling point and rate of evaporation of liquid? A, exposed surface area. B, impurity. C, nature of the liquid. D, pressure. E, wind. The correct answer is pressure. Why? Exposed surface area only affects rate of evaporation. The larger the exposed surface area, the larger will be the rate of evaporation of the liquid. B, impurity only affects boiling point. However, it does not have any effect on evaporation of liquid. Nature of the liquid we could say that it also affects both of them, but it's not more pronounced compared to pressure. E, which is the wind, only affects rate of evaporation. It has no any effect on boiling point of liquid. So question 18 is a calculation. It says that a quantity of heat increased the temperature of 220 grams of water from 8 degrees to 18 degrees Celsius and increases, meaning that the same quantity of heat that increased the water from 8 to 18 also increased the temperature of equal volume of oil of mass 150 grams from 8 degrees Celsius to 32 degrees Celsius. Now we are asked to calculate the ratio of the specific capacity of water to that of oil. So here, solution. So we are given that the quantity of heat, we've already established the fact that the quantity of heat for water is equal to quantity of heat for oil. Exactly. So the mass of water is given to be MW is 220 grams, and the initial temperature of water, call it θ1 for water, is equal to 8 degrees Celsius, and final temperature of water, θ2, is equal to 18 degrees Celsius. Are we together? Now, what we don't know here is the specific capacity of water. We don't know. So let HW be the quantity of heat that raised the temperature of water from 8 to 18. That will be mass of water times specific capacity of water times change in theta for water. Exactly. That will be mass of water times specific capacity of water multiplied by θ2 minus θ1. So evaluating it or substituting the value, mass of water is 220 multiplied by specific capacity of water times change in theta, which is 18 minus 8. So that will give us 220 times specific capacity of water times 10, that is 18 minus 8. In that case, the heat required to raise the temperature of water is equal to 220 multiplied by 10, that will be 2200, then multiplied by specific capacity of water, which is C, W. Are we together? Now, also in the same vein, let H for oil be equal to mass of oil times specific capacity of oil times change in what? Change in theta for oil. Is that clear? That will be equal to mass of oil multiplied by specific capacity of oil multiplied by initial temperature of oil is also 8 degrees from the question, 8 degrees Celsius, minus final temperature of oil is what? 32 degrees Celsius. So in that case, the quantity of heat required to raise the temperature of oil, H0, will be equal to mass of oil is 150 multiplied by specific capacity of oil, we don't know, then multiplied by initial temperature, final temperature is 32, is 32, all right, minus initial temperature, which is what? 80 degrees. So 32 minus 8, that should give us 24. So when you multiply 150 by 24, that should give us what? That should give us 3,600. So I have 3,600 CO, that is specific capacity of oil. I hope we are together. Now we have established the fact from the question that heat required to raise the temperature of water is equal to the heat required to raise the temperature of oil. So we can now conveniently equate this 2,200 specific capacity of water equal to 3,600 multiplied by specific capacity of oil. Remember, what we are asked to calculate is the ratio of the specific capacity of oil to that of what? Of water to that of oil. So we are actually looking C ratio of CW of water CO. That's what we are looking for, which is the same thing as what? CW all over CO. Remember, ratio is a form of fraction. So from this, how do we achieve that? For us to achieve that, we first of all divide both sides by CO. So I have 2,200, right? CW divided by what? CO, which will be equal to 3,600 divided by what? 3,600 CO divided by CO. So CO, we cancel this CO. We'll be left with 2,200 CW all over CO equal to what? 3,600. So this implies for us to get this one, look at it here. For us to get this one, you divide both sides by 2,200. So in that implies CW all over CO will be equal to 3,600 divided by 2,200. And when you do that, that will be equal to 18 all over 11. Are we together? So this implies that CW ratio CO is equal to 18 ratio 11. I hope we are clear. So as simple as this. There's no challenge. Are we together? So from this option, we have option that says the answer is option B. We have 11 ratio 18, but I'm convinced the answer is 18 ratio 11, because if you are to find it will be 11 ratio 18 if you are to find ratio of oil with respect to water, but the question says we should find what? Ratio of water with respect to oil. So I don't think there's any mistake from the way I solved it here now. I hope we are together. So let's look at question 19. 19 says a gas of pressure 2 Newton per meter squared and a temperature of 37 degrees Celsius is heated to 8 degrees Celsius at constant volume. Calculate the new pressure. I think this at constant volume, that is pressure law. So we have pressure law P1 all over T1 is equal to P2 all over T2. We can manage this area to solve it on this here. So our P1, what's our P1? P1 is equal to 2 Newton per meter squared. That is our P1. And our T1 is what? T1 is equal to 37 degrees Celsius. Is that correct? What else are we looking for? We have our T2. Our T2 here is equal to what? 80 degrees Celsius. Then we are looking for P2. So from this formula, P1 all over T1 equal to P2 all over T2. Is that clear? Okay, so maybe we should clean part here and solve it, right? So let's clean this area. Putting our formula, that is what? P1 all over T1 equal to what? P2 all over T2. So what are we looking for? P2. Can make P2 subject to the formula, cross multiply, Tutorz method. So I have P2 will be equal to P1 multiplied by T2, everything divided by what? By T1. So what is my P1? My P1 is 2. P1 is 2 multiplied by T2, which is 80 all over T1, which is 37. As simple as this. 2 multiplied by 80 gives us 160 divided by 37. 160 divided by 37, that should give us 4.3. So we have 4.3 Newton per meter squared, which is what? Option A. Option A is 4.3 Newton per meter squared. That is this option. Are we together? So we are going to stop here in today's class. Okay, we need to complete it to question 20. Sorry, question 20 says electric charge on the surface of a conductor would be evenly distributed if the shape of the conductor is A, conical, B, cuboid, C, cylindrical, D, elliptical, E, spherical. The answer is what? Is E, spherical.